A function is continuous on the closed interval from -5 to +3, such that f of -5 is 3 and f of 3 is -1. The functions f prime and f double prime have the properties given in the table below. Sketch a graph that satisfies the given properties of f. All right, to begin, let's first graph our endpoints of our function. So we have when x is -5, its function value is +3. So it's going to go right about here. And then when the function is evaluated at x equals 3, it's going to have a y value of -1. All right, so we have our beginning and ending points, and now we're going to follow the table in order to graph the function that we have. So when x equals -5, the derivative of f is equal to 0, and its second derivative is negative, meaning it's concave down. So that tells me that at x equals -5, I'm going to have a relative maximum value there. And then from -5 to -2 for our x values, both f prime is negative and f double prime is negative. So that means I'm going to have a decreasing function that is concave down. It's going to look something like this. And then at x equals 2, both the first and second derivative do not exist. So that means we're going to have a corner, a cusp, or vertical tangent. And we can figure that out within the next part. We have a positive, so we are increasing first derivative, and a negative second derivative, meaning we are still concave down. So it's going to look something like this, and when it comes to that does not exist point, it's going to be more of a cusp there. And then when x is equal to 1, our first derivative is going to be 0, and our second derivative is negative, so it's concave down. So that's going to be a relative maximum value. And then to the right of +1, we are going to have a negative first derivative and a negative second derivative, so we're going to decrease and be concave down. And then at x equals 2, we are still going to decrease, and we are going to have a second derivative equal to 0, meaning that at x equals 2, we're going to have a point of inflection. And then from 2 to 3, we are still going to decrease, but we are going to have a positive second derivative, meaning we're going to be decreasing and concave up like this. So that tells me that at x equals 2, we're going to have that switch occur from concave down to concave up. And then at x equals 3, we are going to have a 0 first derivative and a positive second derivative, meaning it's going to be concave up, and we're going to have a relative minimum value here. Okay, so let's try to put all of these things together into our actual graph. This was kind of like a sketch or scratch work to kind of show what our function is going to look like a little bit. And now let's put that to the graph. So we're starting at -5, and we are going downward until we get to -2, and that's where it's going to come to a sharp corner or cusp or vertical tangent. And then we're still going to be concave down, and we're going to go, that's from -2 to +1, so maybe at about here we have this type of function. and then we are going to have negative and still be concave down, but then at 2 we switch and become concave up until we get to this x coordinate here of 3. So here is that point of inflection where it switched from being concave down to concave up, and the rest of it, it's concave down or does not exist. And now let's see what the graph looks like. And this does generally resemble the graph that we drew. See how it has that cusp, and then this one's a little bit less of a coming to a point, so it's a little more subtle here, but we can still see the changing concavity here as well as here.